Hello, my name is John Lemke, and today I'll be giving my TED Talk on fuel cells and the desire for a cheaper electrocatalyst with inside the fuel cells, and why it would be beneficial to change out the electrocatalyst that we currently use in industrial applications. Why and where do we use fuel cells? Fuel cells are used in a variety of applications, and in today's presentation I'll be talking more about proton exchange membrane fuel cells, as proton exchange membrane fuel cells are used in portable applications and transport applications, namely the Toyota Mirai, which uses the proton exchange membrane fuel cell to power the car in replace of a regular gasoline combustion engine. And the fuel cell works as a way to reduce emissions, carbon emissions in the environment, and can overall be cheaper if we address the problem with the electrocatalyst it uses. So how does a fuel cell operate? Well, a proton exchange membrane fuel cell operates as there's a gas diffusion layer in which hydrogen gas, which is the fuel, enters and gets separated in that diffusion layer, with electrons going up into the anode while the non-negative ions go through a semi-permeable membrane, which is known as a membrane exchange assembly. The non-negative ions go in there, and while the electrical current goes through the external circuit and produces an electrical charge, which produces the energy used to power a fuel cell. Eventually, the electrons come back down within the cathode. It gets oxidized by oxygen, and it creates heat and water as a byproduct. So what is an electrocatalyst then? An electrocatalyst is what is used to speed up the electrical chemical reaction. Namely, it lowers the activation energy of a half reaction. And without the electrocatalyst, we wouldn't be able to power the fuel cell, as we wouldn't be able to generate enough electricity, and it would be even more sluggish than it is now to reach that activation barrier to get the half reaction going. And this is different compared to a regular catalyst, as the electrocatalyst used is used in a heterogeneous reaction, meaning that electrons are involved and the element is separated rather than combining with another element. It separates by itself and disassociates. So why do we use a platinum catalyst? The reason why platinum catalysts are used, as they were originally used and they have a good effective surface area, as well as they have a low operating temperature, which makes them desirable. Even though platinum catalysts are desirable and have been increased 10 times fold, there is a cost barrier to them. And that cost barrier is that it's not cheap to produce them. Obviously, it's a normal metal, and normal metals is more expensive than other type of items available on the market. Also, with the platinum carbon cells, fuel cells, electrocatalyst, there's a risk of poisoning in the cell, as there's carbon that's deposited onto that electrode to keep it in place that can over time be oxidized and create carbon monoxide poisoning. Also, methanol fuel in some of the electrochemical fuel cells can cross over and cause methanol poisoning. Also, platinum, after being used for a while, the effective surface area gets lower and the kinetics become more sluggish, especially in the oxidation reduction reaction, which is the electrocatalyst half reaction that takes place in the cathode. So what I have done in my research with other people is try to synthesize and characterize a platinum-free electrocatalyst, and we do this by using a carbon-based metal electrocatalyst that has been used to be replaced since a while, since platinum has been introduced. And we're doing this by using iron thiocyanine and a graphene dispersion. The graphene dispersion is similar to how the carbon is dispersed onto the electrocatalyst in a regular fuel cell, with platinum being the main metal used. And we did this by using FTIR and UV vis to characterize it to make sure it's correct substance. And we also ran cyclic voltammograms and linear sweep voltammograms to make sure that it functions and can produce a working current based on its potential. And as you can see by the graph, it does it cyclically, meaning it's the same. It's similar to how a regular fuel cell works. And as a fuel cell works, for the proton exchange membrane fuel cell, as the cyclic shows that it has a fast start and on and off cycling characteristic, which is why PEMFCs, which is an abbreviation for platinum proton exchange membrane fuel cells, is chosen for fuel cell applications. That concludes my presentation. Thank you for watching, and I'll put the references later.